Question number 10 is basically the same question as question number 6, just looked at from the opposite direction. So it says a rectangular page is known to contain 52 square inches of print. So we know how big the print is, and we know how big the margins are, and we want to minimize the paper required to do this. So it's the same idea as number 6. What we're going to start off by doing is getting the paper with the print on the inside. And what we want to do is minimize the size of the paper necessary. So we know that the top and the bottom are 1.5, and the left and the right are 0.75. Now, what's a little different from this question and question 6 is what we know is the inside. So what I'm going to do is call the inside X and Y. For the same reason we did earlier, that's going to give us an easy expression to rearrange for X or Y. So X times Y is 52. That makes the paper X plus 1.5 and Y plus 3. So we're trying to minimize X plus 1.5 by Y plus 3. The catch to that is it has too many variables in it. So we're going to come back up here and say something like X equals 52 over Y, meaning 52 over Y plus 1.5 times Y plus 3 is my function. Distributing that out, 52 over Y times Y is 52, 1.5Y. 52 times 3 is 156 over Y, and then 4.5. That is now going to be my function. So I'm going to take the derivative. My derivative just becomes, I'm going to turn 1.5 into a fraction because it'll be easier in the next part. So it becomes 3 over 2 minus 156 over y squared. So now we want our critical values. Our critical values are what makes this 0 or undefined. Well, undefined is 0. It can't be 0, so we can ignore that. So now we just need to know what would make this 0. So it's when 3 halves equals 156 over y squared. So kind of cross multiplying that, 3y squared equals 312. So y squared equals 104. So y is equal to the plus or minus the square root of 104. Now, because y is a length, y is the square root of 104. Now, to get x, we're going to plug back into our original problem. This can also be written as 2 square roots of 26, and maybe that works out nicer in the end, but either way, those are my y values. So my x, we're going to plug back in here. You're probably going to want to use a calculator for this part because that's a little hard to figure out. But basically what happens is you get 52 over 2 root 26, which is 26 over root 26, which is also root 26. So basically, your paper is going to turn out, or your print rather, is going to turn out to be root 26 by 2 root 26. Now, we're going to justify and figure out if we answered the question. So first off, justifying my second derivative, 3 halves is going to go away, so we're just going to get positive. 2 times 156 is 312 over y cubed. Whatever y is greater than 0, so that's concave up. So that is a minimum, which is what we needed it to be. And then my question was the dimensions of the actual paper. Well, the paper is root 26, if that's my x dimension, that's going to get plus 1.5 inches by 2 root 26. If that's my y dimension, we're going to add 3 inches to that. Now, if you're doing this in the calculator, this is about 6.6 inches, and this is about 13.2 inches. So that becomes the answer to my question.